I'm Peter Todd. I'm a professor of cognitive science at Indiana University, and I'm interested in a big question of why does intelligence exist? Maybe that's too big to start with. Let's start with something easier, like why don't we just sit around like big blobs waiting for things to come to us? Because we could do that, like sea pens do. Sea pens are simple creatures that live attached to the sea floor, waiting for food particles to float by them, filter them out of the water. And sometimes we humans do that too, like sitting around home waiting for dinner and everything else to be delivered to us. Creatures like these sea pens are exploiting the local environment, using what they can access from where they are. But maybe there's another location over the next hill on the seafloor where a lot more food drifts by. An organism that could find that better location and exploit it could do better than the stationary filterers, growing more and having more offspring. So exploring, in addition to exploiting, can be advantageous. But things change, and that better location with more food may not stay better for long. Other mobile organisms could move in, for example, and then competition could lead that location to become overexploited, with everyone else consuming too much of the food. And this would make it worthwhile for any individual organism to do another round of exploration and find another new place to exploit. So because the resources in the world are unevenly distributed, that is, there's more good stuff in some places than others, and because the world changes over time, that is, the good stuff in a given location can get used up. Therefore, organisms have evolved to explore for good sources of the resources they need and to exploit them once they find them, and then move on to explore some more when the local resources run low. And that's why we're mostly not immobile blobs. We can do better by moving around, seeking resources, and along the way, intelligently deciding when to stay, that is, to stick in one place and exploit what we've got, and when to go, to leave and explore for something better. Making this exploration-exploitation trade-off appropriately is one of the main functions of intelligence. And it's not just that intelligent exploration and exploitation is responding to the challenges of finding resources in the environment. Organisms searching for and using those resources are themselves shaping their environment, creating exactly those changing, clumpy patterns and resources that intelligence is seeking to tackle. It might seem simple to achieve this balance between exploration and exploitation. For instance, you might think, well, just split your time 50-50 between exploring and exploiting. But since we're often not getting resources while we're exploring for them, you really want to spend as little time as needed with exploring and focus on exploiting. Still, when exactly should you explore, and how, and for how long? Doing it well has deep implications for intelligence. You might not be convinced. Wait a minute, you may be thinking, I don't forage like an animal. But studies, including our own, have shown that people do make decisions about staying and going between resource patches in ways that other animals do. For instance, in one experiment where we had people go fishing in a sequence of virtual ponds, people decided to give up on a pond and go look for a new one after it had been too long since they caught a fish the last time there. They were making patch-leaving decisions like some other species do. Okay, you might respond, but I don't spend that much of my time searching for food. And anyhow, that's not what distinguishes human intelligence from other animals. However, we do spend a lot of our time searching for other things. A job, or a place to live, or friends, or a new pair of good headphones, or a parking spot, or something decent to watch on Netflix. These are all cases where people have to decide, is what I've found so far good enough to stick with? Or should I keep on looking for something that could be better? Maybe this still doesn't sound intelligence-y enough? How about searching for concepts in our memory or solutions to problems? These kinds of behaviors are often taken to be hallmarks of high-level intelligence. And they also involve careful interleaving of exploration and exploitation, looking for high-reward areas of the space of concepts or the solution space of a problem. To see this, start searching your memory for all the different kinds of animals you can think of. Say them out loud for a few moments and see how many you can come up with. Like lots of people, you may have started with dog, cat, or cat, dog, depending on your personal preference, and then said a few more kinds of pet animals like guinea pig, hamster, maybe ferret, before running out of pets, pausing for a moment, and then starting with another kind of animal, maybe farm animals like goat, chicken, pig, horse, cow, then running out of those, pausing, searching your mind, and thinking of something else like sea creatures, including dolphin, whale, shark. People doing this semantic memory search task typically switch back and forth in this way between exploiting a cluster of a particular kind of animal, running out of those, and then deciding to explore for a new cluster of some other kind of animal. The same process of switching between exploration and exploitation that we find in actual animals searching for food over a landscape. Only here, the landscape is the semantic space of concepts in our own minds. Not only are the cognitive mechanisms similar for mental search and physical foraging, there's also evidence that our ability to do this advanced intelligent search through mental landscapes evolved from the kinds of neural mechanisms that drove ancestral species searching for food. And if that idea is roughly right, then it could imply that other intelligent life forms that evolved on other worlds, where resources were also uneven and changing, could have similar ways of thinking about the problems they face in their own external or physical and internal or mental worlds, possibly giving us points of cognitive commonality to use in any attempts at communication. Leaving us with a new big question. If and when we meet, what will we talk about?